Hello, everyone. Can you see me? I hope you can. Oh my goodness, I'm so excited to be here with all of you today. Let us get started with our AWS project. So this is Natasha over here from the Network team, and I am here to talk about our latest, our latest AWS networking project. Now, you can find this project in the Nextwork community. If you don't know where to find the Nextwork community or you haven't signed up yet, you can find the link to that in the bio, in the description down below. And let's get started. All right, I'm gonna wait 1 or 2 more minutes just for the people in the chat that are saying that they like a bit more time. That's totally okay. And let's get cracking. Alrighty. Cool. So what you can see is my classic setup, which is my working station, which is the left side of the screen, and then the step-by-step guide for today's project, which is on the right-hand side of the screen. So today we're going to be doing part 2 of Nextwork's AWS networking series. Now you can find this in the All AWS projects page of our community. And when you click on all AWS projects on the left-hand navigation bar, all you have to do is select project 13. And then when you're here, let's select the Start Your Project Here button, and we'll get started straight away. Perfect. So this is what it looks like. Now, what the ideal setup will be is that you have your AWS Management Console with you as well. Now, if you don't have an AWS account, you can absolutely sign up for free, and you can find the link to do that in the What You'll Need section in the step-by-step guide, so it's all sorted for you already. And if you haven't set up an IAM user for your account yet, you can definitely do that in just 10 minutes, and the link to do that is also in the description box of this video. But what I'm doing right now is I've already logged into my AWS account, and I already have my IAM user set up and ready for me to start my project right away today. Now, I am a real big fan of our project today because we have already set up some basics with our Amazon VPC. And what this project is going to do is really build on the foundations that we've set to make our VPC a little bit more advanced. The quick recap is that in our very first networking project, we've created an Amazon VPC. Amazing. We've created a public subnet. Woohoo! And we've also created an internet gateway. Go you for creating that one too. So let's keep diving into the core essentials of building an Amazon virtual private cloud by creating 3 more things in today's project. Now, these 3 things are first, a route table, second, a security group, and third, a network. I almost said Nextwork. Let's create a network access control list, also called a network ACL. So these terms are honestly quite technical if this is your very first time seeing it. So I'm going to let you know right now that there's nothing to be worried about. And really what we're going to be doing today is making sure that everything in our VPC's network can flow from between our VPC and the internet. And second, just really enhance security in our VPC as well. But let's have a quick chat about this diagram before we kick off, I guess, the real practical components of today's project, because I always think it's a good idea to just have a good understanding of what we're doing before we start doing it. And if you haven't done part 1 of this networking series yet, you can definitely find the link to that in the description as well. I'd recommend doing part 1 before you jump into part 2, which is what we're doing right now. But in part 1, like we've mentioned here, you will create the VPC, which is like that pink border you can see here. And then you would have created something called a subnet, which is this blue border over here. And then you would have created an internet gateway, which is this little arc looking thing over here. And as a quick recap, what is a VPC in the first place? So if we were to think about the AWS cloud or your AWS region as a huge country where all of the resources ever created for in that region is in that country. So you can think of it as like a super crowded country full of resources that everyone in that region's ever created. Your VPC is kind of like your own city, your own corner of that country. So the reason why when we create resources in our AWS account, those resources are private to us without everyone being able to see it or access it or take it away from us is because VPCs exist. And they kind of exist as borders or as boundaries around our account so that all of our resources are protected and kind of like held within our area and within our city. The benefit of having our own city is not only that privacy, but it's also the amount of control that you now have for all of the resources in your city. So what that means is you can create little neighborhoods in your city, which are the subnets. So these are like the subsections of your of all of the resources. And you can also set up a lot of things to control the traffic flow. So traffic that is bound for the internet should go through the internet gateway. Traffic that's bound for just within another resources in the VPC should go towards like another resource in the VPC, and you get to control all of that traffic flow. And the other thing is it is just really, really great for the general organization and management of all of the resources in your account. So that's what we've done in part one. And now in part two, when we're creating a route table, this is really just making sure that the traffic that's bound for the internet can get to the internet, and the traffic that's bound for something else internally can get to somewhere internally. So that is called traffic flow management. And then the network ACL and the security group, which are like steps 2 and 3, is just to make sure that we are only letting in and letting out traffic that we're allowing to let in and let out, so that anything that's not authorized or something that we don't approve of can't get in or get out of our VPC. So you can really see here how a VPC gives us a lot of control over our resources and just make sure that our privacy settings are top notch as well. Now, a huge shout out to everyone in the chat, by the way. This is one of the first times that I see everyone saying hello before we even begin the live project demo. So I just want to give a huge shout out to everyone in the chat right now. So that's Person Pro Max says hello, hello. Sindhu says hi. Joe Lagdom says hello. Hello back. Hadri says hi. Hi, Hadri. It's good to see you here. Linda says hi, y'all. Karan. Hey, Karan says hi as well. Abdul Rahman, a big shout out to you. Abdul Rahman says, happy to be here again. Let's do this. Absolutely, we shall. And John, hello, John. Very, very cool to have our amazing, amazing designer in the call as well, saying, woo, let's get cracking. Absolutely, let's get cracking. Okay, so with every single step-by-step project, absolutely we'll start by reminding you, please delete all of your resources by the end of the day, even if you don't finish the entire project. This is just to make sure you don't get charged at all by AWS. And the second thing is, if you're ever stuck, ask the Nextware community. Students like you are already asking questions about this project. This community is all about helping each other out. There's no need to hesitate at all if you're ever stuck at any step. This community is truly full of people who are just excited to help each other out and support each other in this journey. Now, with every single project as well, documentation is just such a big part of that too. So step 0 is to get ready to document. So make a copy of your documentation template by clicking on that blue link over here that's called VPC Traffic Flow and Security. We want to make a copy of this, and I'm going to show you how to do that as well. But before we make that copy, why are we documenting things? I get this question all the time. The entire team does, so we get this question all the time. And the big reason for documenting your work is just so, one, you can really reflect on your learnings. So sometimes when you're in the motion of doing something really practical, you can get really lost in the action sometimes, and writing documentation really makes you stop and reflect. What did I really learn? And can I actually write this in my own words? Second thing is it gives you evidence of the project, the amazing, amazing work that you're creating. So knowing that we're going to have to delete all of our resources, how are we going to show evidence that we've created a VPC, for example? How do we show evidence that we have done a lot of hands-on things in the AWS console instead of just theoretical learning? Documentation is the way that you provide that evidence. And of course, because things on the internet live forever, once you create your documentation, it really is here to stay. It lasts for a very, very long time. Um, so without further ado, click on that link and you'll get taken to your documentation template over here. Now, the documentation template is not something that you can edit directly. So if I try to click into this and try to change the words, change the images, you're not gonna be able to do that right away because this template is for everyone to share. So how do you make this your own? You make a copy of it. How you make a copy of it is over here in the top left-hand corner, we're gonna click on File, and then we are going to click on the Make a Copy button. So this is how you can make your own copy of this documentation template and create your own edits on it. That means you can totally just close this tab that is the original, close the tab for the original documentation template and leave the tab open that says Copy of Documentation Template. So this is your copy. This is yours for you to edit. And the first thing that you could do is highlight Copy of and change that to your name so that you know, oh yeah, this is my copy. This is the copy that I can edit. And I honestly, if I'm making a copy, the first thing I'm gonna do is delete that cover page. This first page doesn't need to stay at all now. You've made your copy, you've done your hard job, you've done the hard work. And now we get to just customize this and make this our own. If you're new to Canva, it is totally okay to take it slow, you know? The first thing you could do to really warm up to a documentation template is by double clicking on the space that says your name. So double click, click, click. Okay, see how it's highlighted now? You can now just type in your name. Oh, Natasha Ong, that's me. And yeah, that is exactly how you can edit text. We're going to be editing this documentation template so much throughout this project. So we're just going to dive into the hands-on portions now so we can see this documentation template in action in just a second. Okay, so oh my gosh, I'm back in the console. I think we're ready to get started now and do some action within the console. Are we ready? I'm super excited. Abhishek in the chat says, hello, Natasha. Good to see you again. Hi, Abhishek. It's so good to see you again, too. Jong? Oh my gosh, that is a cool emoji. Jong has put in a good cool emoji in the chat. Shout out to Jong. It's so good to see you here. Linda's giving a smiley face. Thank you so much, Linda. Supriya Chatterjee, oh my gosh, thank you for being here again. I know you come to these lives so much, and it's always so fun to see you here. Says hello. Cindy says hi. Supriya Chatterjee says thanks for the session. Thank you so much. And Chukwudi, it says hello. Saying a big hello back. All right, let's set up the VPC basics now. Like we said just now in the intro, part one of this project was we were creating the three basic components of a VPC. One, the VPC itself. Two, a subnet, which is like a subsection of that VPC. And then three, the internet gateway. And the internet gateway is basically how your VPC is going to speak to the internet. And we're going to talk a little bit more about these as we go, but really if you want that in-depth explanation for these three basic parts, I highly recommend that we go back to part one of this series so that you can get that slower, like step-by-step explanation. For now, because we're going to start, because the focus of this is about traffic flow and security for this project, we're going to go through these slightly quicker than we did in the last project. But okay, here we go. The VPC is the foundation. So the first thing we're going to do after we log in is to, in the management console, look for VPC. Okay, so you can see VPC over here in my search bar, and I'm going to select that first result, VPC. Very nice. Ooh, doing a little wait. It's making me wait today. That's all good. And this huge dashboard can feel a little bit overwhelming, but this is pretty much like your global overview of your VPCs. And what we really need to focus on is let's just create one VPC today and talk about that one VPC instead of getting overwhelmed by what's happening outside in the entire world. Let's focus on the one VPC you're going to create today, and we're going to do that by selecting your VPCs in the sidebar. And perfect, let's create a VPC. Now in the top right hand corner, there's the create VPC button. So I'm gonna click on that beautiful button over here, create VPC. And here we are to the VPC setup page. Now, um, in the VPC setup page, I think first I should have done this already, but we're going to make sure that the region is the correct region for you. You should be selecting the one that's closest to you. So I'm going to select Oregon, but you can absolutely select whichever region is closest to you right now. And for here in our VPC settings, we're going to select VPC only. If I were to select VPC and more, it shows up this really awesome like graphical way to set up a whole entire VPC and all of its other components. This is a preview of what we're going to do in another project in this series. But for now, let's do everything by scratch so we really understand every single component. And the name for our VPC today, let's call it Classic Network VPC. Cool. Now my IPv4 CIDR is going to be 10.0.0.0/16. So let's put that into that field that says IPv4 CIDR. And as we keep scrolling down, you're going to notice that everything else is pretty much set up and all ready for you. You can just click on Create VPC and you're done. So that was super, super quick. And if you were to just pause for a second and think about what we just did. We just created a VPC. So we just kind of created a whole city within AWS's region or whatever region you're on. For me, I've just created a small city in the Oregon region. And for you, you've created a city in whichever region that you've picked in the top right-hand corner over here. And how do you know the address of your city? So where in that entire country, in that entire region, is your VPC sitting? Now, you can find that by looking at the IPv4 CIDR. We've talked about this in the first part, so if you'd like an in-depth explanation, let's check out part 1 of this series. But as a quick recap, this is exactly how you can write addresses or a range of addresses in IP format. And this is pretty much how you write an address in the world of networking. So in our human world, we might write addresses as like 5 Queen Street in this suburb, in this city, in this country, and this is my postcode. In networking land, this is exactly how we write an address with an IP address. And /16 means that I'm using a really, really big range of, I'm putting aside a big range of addresses, like a whole city's worth of addresses aside for this VPC. So with that done, let's create our subnet now. So the subnet is the neighborhood in your city, and subnets can be public or private. So a public subnet is a subnet where the resources inside can be reached by the internet, whereas a private subnet is one that you want to keep private and confidential, like to yourself. All of the resources in your private subnet is probably something that only your account can see, so people like on the internet won't be able to access it. In this project, we're going to create a public subnet because there's a lot of fun things we can do with a public subnet, and we're going to want to do that today. And how we do that is once you click into the Subnets tab, let's find the Create Subnet button on the top right-hand corner again, and let's click on that over here. Now, this is the Subnets setup page, and here we are just selecting for which VPC, for which city are you setting up your new neighborhood. And okay, well, we've only created one VPC, haven't we? So we're going to select Network VPC. That's the VPC we've created. Click on that. And let's give it a name. Now I'm going to scroll down a little bit here and give it a name, which is Public 1. Not a very exciting name, I'm realizing. You can totally give your subnet a cuter name, by the way, if you want to make it like, I don't know. You can put in your name, be like my public subnet or something like that. It doesn't have to be public 1. And availability zone, let us select just the very first availability zone in the list. And then now we're looking at what is your VPC's CIDR block. So do you remember what was happening in the previous step when we created the VPC? We defined the VPC CIDR block already. So we've already said the range of addresses for my little city is going to go from 10.0.0.0 all the way to 10.0.255.255. That's the entire range of addresses I've set up in this CIDR block. And now what's happening with a subnet is, so within this huge range of addresses that you've created within this huge CIDR block, what is the chunk of addresses you want to give to this subnet? So it's kind of like in this huge city that you just carved out for yourself, from which address to which, from which street to which street is going to belong to this neighborhood, this suburb in your city. So that's what we're doing when we're defining that IPv4 subnet CIDR block. And this number definitely has to be smaller than the entire city's address range. So what we're going to do here is we're going to define a smaller IP address range, and that smaller IP address range we're defining is 10.0.1.0/24. And if you want a recap of what this would mean, definitely check out part 1. But yeah, we've just defined the CIDR block for our subnet, so we've just defined a whole list of addresses for our little neighborhood, and let's just create the subnet. Off we go. That was super, super fast. That was super fast. And it's the reason why the networking series of projects, so this project and the one before, it's going to be a really, really 50-50 mix of hands-on work and also just talking through things and explaining things, just because the creating of things is actually very, very fast, but the understanding of things is probably a little bit slower. So I hope you are very, very patient as we go through these steps to create and also to understand and learn. But awesome. So we've just created a public subnet. And what we're going to do now is we're going to select this little checkbox here and click on Actions on the top right-hand corner. And let's select Edit Subnet Settings. So I'm going to click Edit Subnet Settings, and there's this button here that says Enable Auto-Assign Public IPv4 Address. So I'm going to click on that now, and I'm going to choose Save. Perfect. So what we've done is we've just made sure that any EC2 instance that we launch in this neighborhood will automatically get a public IP address. So this will make your EC2 instance accessible from the internet without you needing to now manually assign it a public IP address, and that's a huge time saver. So if we hadn't ticked that box, what would have happened is, even if we've made our subnet public, if I were to launch an EC2 instance in that subnet, I would have still had to manually go into that EC2 instance and make sure that I assign it, like do this other tick to make sure that it has a public IP address, a public address that anyone on the internet can reach. But because what we just did was enabling the auto assign, that means now if a resource ever gets deployed in my neighborhood, they will automatically get assigned that public IP address without you needing to do it yourself. So yeah, that was a huge time saver, and you're going to see this in action later on in another project. But great setting to have if you're creating a public subnet. Cool. So that was really fast, wasn't it? We have just created a VPC, tick. We have just created a public subnet within that VPC, tick. And now what's next for us is we're going to create the internet gateway over here. So this was step 3 of part 1 of this project. And as a quick recap, the internet gateway is basically how your VPC will be connected to the internet. Now, it's always very easy to confuse your VPC with the internet because you're thinking, well, when I'm creating these resources, all I have to do to access them is I just have to go into my AWS Management Console, and the AWS Management Console is in my browser. That means I'm on the internet. That means my VPC's already on the internet automatically, right? Well, the answer actually is no. Your VPC isn't automatically connected to the internet. That means the resources you create within your VPC doesn't always connect to the internet and be reachable by the internet automatically. So your resources can absolutely still be private and not be accessible by anyone on the internet, in the public space. And that's why internet gateways exist. If you do want to establish that connection, which means if you do want your resources to be accessible to other people on the internet, then you will need the internet gateway to be like that middleman that speaks, that kind of directs traffic from the internet into your VPC and from your VPC outside to the internet. And that's where an internet gateway is super, super useful. So let's just create the internet gateway for us in this step. And how we do that is in the left-hand navigation panel. Let's find internet gateways. Let's click on that. Very nice. And let us create an internet gateway right away. The name for your internet gateway will be very simple. Again, Network IG for internet gateway. And we can just choose create internet gateway. Just like that, we have created the internet gateway already. We have created this entire thing that can connect us, our VPC, with the internet already. That was super, super fast. I think it really goes to show like how quickly you can create resources with AWS. Imagine if we had to like learn how to create an internet gateway from scratch by ourselves. Like, I'll be so confused. So thank you AWS for making it so easy for us. Now, what we've just done though is we have created this internet gateway, and imagine that it's just standing alone in the world of your VPC or in the world of your AWS cloud, like just standing alone like this. And it's not attached to anything. It doesn't even know like that it can connect to your VPC and connect it to the internet. It's kind of like it's just standing there and its arms aren't like reaching out to connect the internet and the VPC yet. So how we need to make that connection is by attaching your internet gateway. And that's what we're going to do next. So as you scroll down here, you'll see the steps to do that. So select your newly created internet gateway and choose actions. So you can also just find the actions in the top right hand corner here. If you select that, actions, you can attach it to the VPC. And over here, select the VPC from the list. Over here, perfect. And you can attach your internet gateway, just like that. Done. So I have just attached the internet gateway. If you've just clicked that, you've definitely attached your internet gateway with your VPC now too. So that's perfect. So what that means now is now that your internet gateway has one arm attached to your VPC and the other arm attached to the internet, you have made sure that any resources in your VPC can now access the internet and be accessed over the internet. So to clarify, because your internet gateway has now connected your VPC with the internet, if you were to, for example, host a website like a website on an EC2 instance, and you put that EC2 instance in your public subnet, ideally now that your internet gateway is attached to the VPC, surely that means people can actually visit your website right away. Because, well, I mean, that attachment is here now. So there's a connection between the internet and your VPC. But actually, there is one more thing that we need to do. So what we've done just now is we've just set up the connection between your internet gateway and the VPC, that big pink blob over here. But if you were to launch a EC2 instance, that EC2 instance is sitting inside your public subnet. And right now, your EC2 instance inside that public subnet doesn't actually know how to get to your internet gateway yet. It's kind of like if you knew that there was a way, like there was a port in your city to leave your city and enter into the world of the internet, but you're kind of living in the forest and you don't really know how to get to that port, you're going to get really, really lost trying to get to the internet. And that's kind of what's happening to resources in your subnet right now. They might know, maybe they could know that an internet gateway exists, but they absolutely don't know how to get there, even if that port exists, even if there's already that connection. So what we're going to do next is we're going to enter into the realm of route tables. So what we've just done so far is we have completed steps 1 to 3, the entire part 1 of the networking project series. So we've just done the previous project. And right now what we're going to do is we're going to get into, I guess, the new territory where we're going to learn some new concepts. The first new concept we're going to learn is the route table. And the route table is like that what is that called? A GPS. So say again, you're in the forest, you're lost. You're like, oh my gosh, I am traffic that needs to get to the internet from within the subnet in my VPC. So let's say you're living inside the subnet and you're like, I need to get to the internet. How do I get there? You would consult the handy route table. That route table is going to pretty much be like a traffic controller that says, go here, go here, turn left, turn right, go straight, and that's how you're gonna go and get to the internet gateway. And then once it gets to the internet, once that traffic reaches the internet gateway, boom, the internet gateway is gonna send it on its way to the internet. So that is why we need a route table. And let's set up one right away. Cool. So in the left-hand navigation panel, let's choose route tables over here. Oh, lovely to see everyone in the chat, by the way. Oh my gosh, I've missed out a few messages. Afik says, hi, Natasha. Hello, everyone in the chat. That's so kind of you. Abbas says, let's go. Abbas, it's so good to see you here. Abdurrahman says, the interface is amazing. Love this. Wow, that's so nice. That's so sweet. Hassan says, hi, Natasha. Saying hi back, Hassan. Plaxides, wow, good to see you again. Plaxides says, hola. Good point. Thank you. Wendy says, nice analogy. I'm glad you appreciate it too, Wendy. I'm quite proud of it myself. So let's now talk about how to create that route table. So once we're here in our route tables page, you're going to notice that, actually, once you're here in the route tables page, click on this refresh button. Okay, before you do anything, click on this button over here. Boom! Did you see that we just went from 1 row to 2? Yeah, that's the thing about AWS, the AWS console. Sometimes refreshing needs to happen because it doesn't, your page doesn't update itself automatically. You do have to click that refresh button sometimes to see like the latest, most recent version of each page. So here is the most recent version of the latest updates for our route tables page, and there's actually 2 route tables in our page already. We haven't created a single route table yet, but there's already 2 things in here. What? Why is that? Why is that? How do we already have 2 route tables? So something that you would have learned in part 1 of this networking project series is that AWS creates a lot of these default networking components for you already. Didn't even need you to do it yourself. Didn't even ask you to do it yourself. It's already created it for you. So, for example, when we created a VPC for the first time, there was already a default VPC. When we created the subnet, there were already 4 default subnets. When we created the internet gateway, there was already a default internet gateway. And all of this is so that your AWS account is set up and ready to start deploying resources, creating resources without you needing to set this up manually yourself. And the reason why you would even do things in a custom way is so that you can organize different projects. For example, if you want a project to live within its own VPC, absolutely you can. They can have its own city. And this makes sure that all of the different projects that you have in AWS are completely customized, like whatever security rules that they need, whatever traffic rules that they need, nothing is going to conflict, right? Because they all live in different cities, different VPCs. And in this case, we already have 2 route tables. So how you can investigate these is you can click on that little checkbox on the left-hand side of each route table. And then you can click on the routes tab here. I think I'm going to zoom in. I have a feeling this page might be a little bit small. Let me know if if the screen is now a bit too cramped, but I have a feeling this previous setup might be a little bit too small for you. So I've just zoomed in now. But if you were to click on the routes tab, once you've selected it, wow, okay, interesting. The first route table has 1 route. Okay, interesting. The 1 route is 10.0.0.0/16, a target that says local. Okay, we don't actually understand what these words mean yet, but that's okay. Let's just investigate that second route table first and have a look at what's going on. So I'm gonna click on that second route table. We're gonna click on routes, and we're gonna have a look here. Okay, this one has 2 routes. Okay, this is 1 more route than the other one. Interesting. So the first route is 0.0.0.0. Did I say 1 too many zeros? Maybe I have. /0. And there's a target that says IGW, okay? And then there's a destination here that's a bit more complicated of a IP address /16. The target is local. So now that we've done a bit of investigation, we've learned that there are already 2 default route tables, one with a single route over here, and one with 2 routes over here. So why is that? So as you might guess, one of your route tables was created with your AWS account's default VPC, so it's been around ever since your account was created. This route table has lived here for some time now, and we're really finally meeting it for the first time. And that route table that's been around since you created your AWS account is this route table that has two routes inside, this one over here. So why is it that when we created our AWS account, these two routes already existed within this route table? Here's the reason why. Now, to understand these, let's decode what these routes mean in the first place. So this first row with the 0.0.0.0/0 means that all traffic that is destined for any IP address at all is target, which is like kind of like this is the path that you're going to be on, internet gateway, IGW. If you click on that, you're going to see it actually takes you to an internet gateway over here. But let's head back to the previous page. Let's head back to my route table. Interesting, right? Isn't it? So the bottom route, 172.31.0.0, which might look slightly different, by the way, for your VPC, and that's totally okay if you have a slightly different set of numbers. This bottom route is telling me that all of the traffic that's bound for another resource within your VPC, so it's kind of like all of the traffic that's not leaving your city, but it's just looking for another building or another resource in your city, is going to go on a route that's called local. And both of these routes exist so that any traffic that's bound for the internet and for anything that's internal within your city has a route that they can go on. Now, I know that can be a little bit of a interesting concept to learn for the first time, so let's just talk about it quickly one more time. Okay, so to understand the bottom route, I think it is a good thing to know. A good thing to know is that this address space is exactly the same IPv4 CIDR block as your entire default VPC. So if I were to click on my default VPC, which you can find if you were just to scroll on your route table and click here, if I were to just click on the VPC that's associated with my route table, let's click on this, right? You're going to see that the IPv4 CIDR block, so the entire block of addresses, the entire block of streets that belongs to my city, that belongs to my VPC, is 172.31.0.0/16. And then if I were to visit the route table that was already set up the moment my VPC was born, the route has the exact same IPv4 CIDR block as the destination. So what that really means is any traffic that is bound for anywhere within the entire VPC is going to go on a target, which basically means like a route or a path or a road called local. And then anything that is like within this scope, if it doesn't fall into this scope, anything that falls within this wider scope, which is the 0.0.0.0/0 is bound for another road called the internet gateway. So I think an interesting thing to notice is what is 0.0.0.0/0? That basically is the biggest IPv4 address range you could possibly have. It means all IPv4 addresses. And then anything that is not that is basically smaller than this IPv4 range. So what this table is truly saying is if you're bound for anything that's within your VPC, you're going to go on a road or you're going to go on a path called local to get there. But then if you're not bound for anything that's within this IPv4 address, you're on a different path right now. And that path is going to be the internet gateway, where the route table is going to take you straight to the internet gateway. You're going to get instructions to go straight to the pier or the dock to leave the city. So I hope that was clear. If it wasn't, please let me know in the chat and we can talk about it even more. But I'm going to move on from that and let's talk about the second route table now. So the second route table, which you can click on over here at the top, if we were to click on the routes tab one more time, Interesting. Interesting. Have a look at what is the IPv4 address range under destination and have a think. Have we seen this IPv4 address CIDR block um, at all before now? Give it a little second. I'm gonna have a little drink in the meantime. Okay, so the answer to that was yes. We have seen this IPv4 CIDR block before now. Where have we seen it? We saw it when we set up Network VPC. So what does that mean? So this route table has the exact same IPv4 CIDR block as the entire network VPC, the entire network city that we just set up like a couple of minutes ago. So what that means is this is a default route table that AWS has created automatically the moment you created your network VPC. So there is a single route. It just says any traffic that is bound for 10.0.0.0/16 is going to go on the local path. Looks familiar to the other one, right? So this one is really saying any traffic that is bound for within the network VPC, the network city that you've set up, is going to end up somewhere else that is also local in that VPC, that is also internal. So this route is truly for internal communication between two resources in your VPC. So that's exactly like the other one that we saw for our default route table for the default VPC in your account. So anything that is bound for within your VPC ends up on the local path, so it's just internal communication happening. Notice how there's only one route, so there's no route for any traffic that is destined for somewhere else that's not in your VPC. So there's actually no route for any traffic that wants to leave your VPC and enter into the world of the internet. There's no GPS for that right now, so that is the reason why traffic in your subnet that's bound for the internet is still going to be confused even if you've created that internet gateway already, because there's no route, there's no way for them to figure out how to even get to that internet gateway. So that's what we're going to create now. We're going to want to make sure that any traffic in our subnet that wants to go out into the world of the internet can know how to do that by giving them the GPS or the directions to the internet gateway. How we do that is in your AWS console. Let's click on Edit Routes over here. And we already have, the default route that was set up for us, and we're going to add a new route to this. And over here in destination, let's make it 0.0.0.0/0. So just like the previous, internet gateway bound route for the default route table we saw before. The target, guess where it's going to go? Out of this list, where do you think internet bound gateway should go in our for this route table? If you've guessed internet gateway, that's correct. So let's select internet gateway in this list. And here, there's only one option. It's the network internet gateway that we set up. Perfect. So let's save our changes. And we have just successfully added a new route to our route table. Lovely. Now, let's summarize what we've just learned with this little comic over here. I think one interesting thing to notice actually is you might be noticing that, hey, look, you've just told me that this IPv4 CIDR block stands for every IPv4 address out there. All IPv4 addresses fall within this CIDR block. Then doesn't that mean it overlaps with some of the addresses covered in this IPv4 CIDR block? Yeah, the answer is yes. So what usually happens when the route table is evaluating traffic is it starts from the most restrictive destination and it works its way up. So what's going to happen here is it's going to evaluate, when it looks at traffic, it will ask the traffic, hey, are you bound for this, which is my most restrictive rule, which is any traffic that's destined for something else locally within the VPC. And if you say no, then it's going to move up. It's going to move up a tier. And it's going to say, oh, okay, no to this. Then let's go move up a tier. Then are you destined for anything else, any other IPv4 address? And it's probably going to say yes, I am destined for some address that's not within this range. Then it's going to say, okay, well, since you're destined for something else that's not within this range, the route table has dictated that I'm going to send you to the internet gateway since you're bound for something else. So off you go. Bye. See ya. So then that's pretty much what the route table does. And that's exactly what this comic is summarizing as well. So what our route table, our handy route table over here is doing is it's basically asking every single piece of traffic, hey, are you heading to another resource in this VPC? Are you heading to another local resource? If the traffic says no, well, okay, no, you are not heading to this bottom row, then I'm going to work my way up. Oh, I only have one other possible route going on, and that is to take you to the internet gateway. So off you go to the internet. So off you go. Here you go. Perfect. Now I'm gonna quickly have a quick look at the chat just so we can catch up with any Q&A. Linda says, Wendy, yes, a good one. I understand better with her analogies. Wow, that's such an honor. That's really, really cool. Supriya says, great explanation. Thanks for clarifying the difficult concepts. So well explained. Wow, I'm really, really glad to hear that. Do you think how we explain routes, well, the route table was okay? I'd love to know. Devil's Lab says, hello. Zuri says, hey, hey. Joe's giving the strong hands. So good to see you here, Joe. Ahmed Yusuf has a question. Ahmed asks, the local IP, is it default? Ooh, very, very good question. So yes, as you would have noticed, the moment we created our VPC, this route was already created for us. So yes, it is by default that the default route table that AWS creates for us is gonna always have a route that says, well, since you've created a VPC within your city, by default, any resource that's bound for something else that's within your own city should be able to travel there, right? Like it should be able to visit there. So by default, there's already a local target created for it. Cool. Oh, Ahmed says, okay, cool. Glad we're all clear now. That's great. Okay. Oh, perfect. So let us take a screenshot of Route 2 of our route setup page, and we'll use the screenshot in our documentation soon. Shall we do that right now? I think let's do it. Let's do it. So let's click on Edit Routes to head back to our route setup page, and let's take a screenshot of Route 2. So I'm going to take a screenshot like this. I think it looks pretty good. And we're going to move on. Perfect. Okay. Very, very cool. So, oh, I have not made any changes. That's cool. Okay, so I've saved that screenshot, and I'm going to use that in my documentation in just a second. And what we're going to do next is we're going to associate our route table with the subnet now. So what's happening here is there's already a subnet that is already associated with this route table, and it's called subnets without explicit associations. The following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. Okay, so that was a little bit of a confusing sentence, I feel. But what it's really saying is this page is telling you, hey, I've scanned all of the subnets. I've scanned all of the subnets in your region right now. And I've picked up that this subnet that you've created, which is our public subnet, doesn't have a route table that is associated with right now. Because it doesn't have any route table that is associated with right now, we're just going to associate it with the main route table. And when you see the words main route table, that is basically the default route table that AWS has set up for your account when your account was born. So that was the route table that we saw just now that already had 2 rows existing. All subnets that aren't explicitly associated with a route table automatically gets associated with that. So what that means is if any traffic within your VPC is trying to reach somewhere else, that route table, that main route table, is going to be the GPS that it's using to get to its destination. But that's not exactly the right GPS for our public subnet, because this this route table that we've just created, this GPS that we've just created, has better, it's more specific to the range of IP addresses that's in our VPC that we've created. So we're going to say, oh, okay, I see that by default, it's using the GPS that AWS has created for my VPC when my account was born, but I'm going to explicitly say, don't use that GPS. Please use the GPS that I've just set up. And that is basically the association. So all you have to do is click Edit Subnet Associations on the right-hand corner, and then you're going to check the subnet that you've created, your public subnet, check it, and then save the association. Okay, so what that does is it's basically saying, I want to make sure that all of the resources that's within my public subnet, the GPS that they're using to navigate their way around my VPC or get to the internet gateway, is this GPS that I've just created over here. Cool. Was that all good? I hope it was. So we're going to now move on into our documentation time. So one thing that was very, very special, I think that we didn't get to cover just now very, very clearly, is the fact that even though our subnet is called public 1, naming it public doesn't make it a public subnet. That's not the criteria, unfortunately. The criteria for a public subnet is that it has a route to the internet gateway. Let me say that one more time. A subnet is considered public if it has a route to an internet gateway. So previously, public 1, was it a public subnet? Does it have a route to an internet gateway? So technically, it really became a public subnet when it got connected, when it has this route now to this internet gateway that we've just set up. So that's awesome. Now let's go into our documentation template and just fill this in. So we're gonna head to the tab, the slide, I think that's called route tables, and let's paste the screenshot that we've taken just now for the route that we've created over here. Perfect. And let's fill in the prompts. So, by the way, I'm so happy with the way that this just fit in perfectly with the frame. I always find it a little win when my screenshot just fits into the frame perfectly. It's just so nice to see. But let's fill in the prompts now. What are route tables? Route tables are like the GPS that directs traffic within my VPC to the correct destination. Route tables are needed to make a subnet public because a subnet needs to have a route to an internet gateway in order to be considered public. A route table is the only way to establish this connection. A route table is made up of routes, which are defined by its destination and the target. So the destination, which we would have learned, so the destination and the target basically define the routes that are in your route table. So the destination, what is that? The destination is the range of IP addresses that traffic in my VPC is trying to reach. The target is, I would like to say the target is how they will reach their destination. But I think there's like another kind of definition that we've put into the step-by-step guides. We're going to check that very, very soon. So the target is the road or path that the traffic will have to take to get to that destination that they're looking for. So the target is the road or path that the traffic will use to get to their destination. Perfect. I'm gonna quickly have a look here again. Okay, cool. I noticed that my documentation is looking a little bit long. Classic, just classic net for making the documentation a little bit wordy. But I'm going to just decrease the font size a little bit here to make some space. Okay, the route in my route table that directed internet-bound traffic to my internet gateway had a destination of, do we remember what is that IPv4 CIDR block that represents all IPv4 addresses? It was 0.0.0.0 slash 0 over here. And a target of my network internet gateway. Cool. So to recap this, the route in my route table that directed internet-bound traffic to my internet gateway had a destination, which is the range of IP addresses that the traffic is trying to get to, had a destination of 0.0.0.0 slash 0, and a target of my network IG. And that is basically just explaining this row in words. That was all we did with that bullet point just now. Awesome. So with that done, let's move on to the next step. So that was an awesome step, by the way. A route table is huge for a VPC because, as you would have observed, or as we've just covered, absolutely resources in your VPC will need that route table in order to figure out where they need to go to get anywhere. So if that route table didn't exist, they're truly in the forest forever, never knowing how to get to the dock or the pier to leave the VPC and enter the internet gateway, or even to find a fellow resource that's within that VPC. So that's why route tables are just so important, and that's why they're considered kind of like the traffic flow of the traffic flow part of this project today. But we have just ticked traffic flow, perfect, with the route table, tick. And don't forget, this project is called Traffic Flow and Security, and now we're going to reach the security aspect of this project today. So what we're going to do now is we're going to create a security group, and what a security group means, all that stuff is stuff that we're going to learn as we go. So no stress if this is your very first time seeing a security group. You can absolutely do this as a complete beginner too. Now, this diagram shows us that we're going to create a security group inside our subnet. Very interesting. But please note that in this step of the project, we're not actually going to create that EC2 instance inside. It's kind of here for illustration purposes, and you'll see why in a second. What we're really going to create is the security group itself, not the EC2 instance that's inside. I'm just going to quickly look at the chat as well. Ahmed says, can you quickly go over the IPv4? More than happy to if you'd like to let me know what about the IPv4 you'd want to know about. In short, IPv4 is pretty much the way that we write addresses in the world of networking. And Supriyo says, what would be the advantage of implementing NAT? Interesting. And how can it be implemented in this specific architecture? Very, very good question, Supriyo. So what you've asked is actually something that we'll explore in the next project after this. So without revealing too much, because I feel like it might distract us a little bit from the scope of today's project, an NAT becomes very, very helpful when we have a private subnet. So what we've created so far is a public subnet, and the benefit of having an NAT is going to come through if you ever create a private subnet where you really want to almost like protect it from the internet, but there's also going to be a bit of traffic that might want to reach the internet from within the private subnet. So there's a bit of there's some interesting stuff that we can do there, and we'll talk about that a little bit more in the next project. Cool. Hassan says, and the routes are like, ? Are you meaning the routes are like, is this something that I wrote in the documentation template? Is this something I missed? The routes are like the GPS that directs traffic. Maybe there was a bit of a time lag there, but definitely let me know what you were looking for in that question too, Hassan. Sorry, I must have missed the timing when you asked that question. Ooh, good question from Abdul as well in the chat. Can multiple subnets be associated with a single route table? Very, very good question. And the answer is yes. So multiple subnets can be associated with the same route table, and you can actually see that with the default route table that gets created in your VPC. So remember how we said that this route table was created the moment your VPC was born? If you were to look at the subnet associations for that, look at that. 4 subnets without explicit associations are now using the main route table. So what that really means is definitely multiple subnets can be associated with a single route table here. It doesn't have to be one route table per subnet. Absolutely, multiple subnets within your VPC, within your city, can be associated with the same route table. Cool, I hope that was clear, and great question, Abdul. Okay, so let's talk about security groups now. And first of all, we're going to click into the security groups tab in our AWS console over here. Security groups, perfect. And you're going to notice, again, we have default security groups. So we're going to talk about the default security groups in just a second. But let us first understand why security groups exist in the first place. So what is a security group? A security group is like a security guard for every single resource in your VPC. So we've talked about VPCs are like your city. Huge. VPCs are huge. Subnets are neighborhoods, still big, but slightly smaller. Okay, over here, subnets are like little neighborhoods, little subsections of your VPC. And now think of security groups as another unit smaller. Where neighborhoods is like a collection or a neighborhood of resources, security groups are for every single resource, per resource. Every single resource has a security group. And what that means is even if you have a subnet with many different resources inside, all of those resources belong to the exact same subnet. They belong to the exact same neighborhood. They belong to the exact same neighborhood over here. But every single resource will have their own security group. So it's kind of like picture a house or picture a neighborhood or a suburb. And imagine if outside every single building in that neighborhood, there was a security guard standing outside like this. One security guard per building. And now think of that security guard as a security group inside your VPC. There's going to be one for every single resource in your VPC. So you can think like there are many of these security groups. So what do these security guards do? Imagine if you had that security guard standing outside every single building in the neighborhood. And that security guard is going to check every single person that's coming into the building and every single person that's leaving the building as well. It's like checking both ends. It's almost like checking like, are you allowed to even come into this building? And it's also going to say, are you even allowed to exit this building right now? And that's exactly what the security group does for all of your resources as well. Perfect. So how do security groups actually work in the networking sense? So we've just mentioned that security groups are responsible for checking who comes in and who goes out. They have strict rules, and how they decide whether or not some traffic can come in and whether some traffic can leave is by checking every single piece of traffic's IP address, their protocols, and their port numbers. Ooh, interesting. Some new words here, okay? So we have IP address. We already know what these mean. We kind of know protocols, maybe. You might have come across this word before, but you're less likely to know what port numbers mean. So let's talk about protocols and port numbers very quickly. So if VPCs are the city, think of protocols. If VPCs are the cities, we have subnets as the neighborhoods. We have resources as buildings inside your neighborhood. We have security guard groups as security guards outside every single building. Now we're going to talk about protocols. And protocols, you can think of them as the different vehicles, the different like vehicles like buses, taxis, and trucks that will deliver the traffic. So you are traffic, you're trying to get from one resource to another, from one destination to another. How are you getting there? I'm going by bus, I'm going by taxi, I'm going by truck. Protocols are different ways to move data across the internet, to move traffic across the internet. But most specifically, let's talk about data instead of like the word traffic. Let's talk about data. And protocols are designed to send data for a specific kind of task. So in the city, why do we have different kinds of vehicles? If we were to just think about our city, why do different kinds of vehicles exist? We'll be like, oh yeah, buses exist as public transport. Taxis are like private transport that's quick and efficient and private. Trucks are here to really just hold some like rubbish, for example, or like carry a lot of heavy things around the city. And protocols exist for that reason as well. Um, data can get delivered in different ways in different vehicles in a network because different kinds of protocols specialize in moving different kinds of data. So here are a few examples of protocols to really make that concrete for you. HTTP, this might look very familiar, isn't it? Yeah, HTTP is at the front of every single URL that you might have come across, or it could be HTTPS. But HTTP is the standard protocol, or like the standard vehicle for sending web pages over the internet. So just like buses carry passengers, HTTP carries web page data to your browser. And the next example is SMTP, which is the standard protocol or like the standard vehicle for sending emails across the internet. So very interesting concept to be learning about. Protocols basically expose you to the fact that different kinds of data needs to be sent in different kinds of ways. And those different ways are called protocols. So imagine if emails are all sent with mailmen that always make sure that the email gets to the correct inbox. Now, there are also other protocols. This one is called FTP. FTP is a protocol, file transfer protocol, that's like that huge delivery truck that's used to transport large loads of files between computers on a network. So FTP is a protocol that's very popular for uploading and downloading bulky items to and from servers. Developers often use FTP to upload website files, but really, I think enterprises are huge users of FTP as well, because imagine the huge amount of data they might want to transfer to and from in mass. SSH, Secure Shell Protocol, it's like that secure private car that allows encrypted communication directly with another server for private tasks. So you can think of SSH like that dark like limousine where you can't really see inside, you don't really know what's going on, but you absolutely know it's transporting some data across the network right now. So extremely secure and private. You'll come across SSH, by the way, in more advanced projects in the world of AWS, and we'll absolutely get to touch on it in the future again. So that was protocols. So you've just learned that protocols are different ways to move data based on the type of data that you're trying to move. And again, how is that related to security groups? Security groups is evaluating traffic based on IP addresses, protocols, and port numbers. So it's going to evaluate where this traffic is coming from. It's going to evaluate what kind of data it's moving, it's transporting into your resource, or the kind of data that's trying to exit the resource. And it's also going to evaluate based on port numbers. So what are port numbers? Think of port numbers as the specific doors or delivery docks on a building. So we just know every single resource in the VPC in your subnet is its own building, right? Imagine if that building has tens or hundreds of doors all outside that building. Many, 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 many doors. And imagine if you are one of those vehicles that's delivering data over here. There is a specific door made for the kind of data that you're delivering. So to put that as another analogy, for all of you who are a fan of analogies, I'm a big fan too. Imagine if your house doesn't have just one entrance. Imagine if your house had a different entrance for the different kinds of things that could be delivered to your door. For example, I can be like, all Uber Eats, all food through this door. That is the door that I'm going to use to open the door and accept my Uber Eats. If you were to deliver to me groceries, yeah, I'm going to accept that through another door. Another door exit, like through another exit for my house, for my building. Oh, you're gonna give me a microwave? Okay, I accept appliances through this door. You're gonna give me furniture? I accept that through this other door. Imagine if you can't accept everything that gets delivered to you from one big entrance door. Imagine if you have to separate everything into different doors and only accept specific items through a specific door. That's exactly what port numbers are. And when you have EC2 instances like servers, they will have port numbers designed for specific protocols. And the reason why port numbers exist for an EC2 instance is because that port number is pretty much like gonna give the thing that gets delivered to them a highway to the right application or process that's capable of processing that protocol. So what that really means is your EC2 instance is huge, right? There are so many things that your EC2 instance could be running, and within your EC2 instance, there are specific tools or specific applications that's inside that EC2 instance that's designed for processing all emails. This specific application is designed for loading web pages. This specific process is designed for handling file transfers. So because there are specific things in your EC2 instance that's designed for processing different kinds of data, you're going to want to set up different doors that's pretty much going to let in the data and give it the most efficient path to get to the process you've set up for processing that data. So you can really think of port numbers are here for efficiency, to make sure that any kinds of data that comes into your resource has the most efficient path to get processed straight away. And that is exactly how an EC2 instance can handle so many different applications or run so many different things at the same time. So without port numbers, an EC2 instance would absolutely struggle to manage incoming data. It wouldn't know what kind of application or service each piece of data should be directed to. There's definitely common port numbers that exist as well. Like port 80 is often the port number for the HTTP protocols that's delivering the web pages. Port 25 is the common port for SMTP protocols, which is the protocol that delivers email. And then port 21 for like the FTP protocols that's doing the file transfers. So you can think of like multiple doors all leading to different kinds of processes for processing the kind of data coming through to your EC2 instance. And security groups can absolutely filter traffic that can come in or get out based on the port number as well. For example, a security group can say, "Oh, you're trying to enter this door. You're gonna try enter my port 25 that's for SMTP protocols or for email. Well, sorry, actually, Saprio has set up this security group so that I am not gonna accept any email at all. Well, since I'm not accepting any email at all, anything that's gonna try to access my port 25 can't come in. Sorry, I'm not accepting email. For security reasons, I'm not accepting this kind of data. So if you're going to try to access me through this port number, well, that door is locked. I'm not opening that door. I'm not letting you in. So you can think of it, your security group as, that security guard that can filter out traffic in these kinds of ways. Cool. I know that was a bit of a tangent. We just went from security to something a little bit more technical like protocols and port numbers. But really, you're going to see these kinds of terms pop up a lot of the time when you're learning networking, and it's great to set up these foundations now. All right, so we already have existing security groups in our AWS account. So AWS creates a default security group for every VPC in your account, and your default security group is going to allow all traffic. It's going to have pretty much no filter at all. It just lets in all traffic that comes in, all traffic that wants to go out. That's all you need to know about the default security groups that lives here already. So if you have a security group that says Cloud9, by the way, it's a default security group that was created for you when you did our DevOps project series, which is the series of projects before this series, the networking series. So if you see a security group that says Cloud9, don't worry. It's something you can definitely delete. It's just something that just popped up by default when you did that DevOps project series. But yeah, nothing to worry about if you see a security group there. It is completely free to keep security groups. AWS doesn't charge you for creating security groups at all. So you can definitely leave security groups in your account without worrying about being charged. Just as a heads up. Cool. Okay, so finally, let us create a security group after all of this learning about how security groups work. So let's click on Create Security Group in our account. And our security group name over here is going to be Network Security Group. Perfect. And it's going to have a description called a security group for the Network VPC. Okay, thank you very much. And the VPC that your security group is going to be associated with is your Network VPC. And now under inbound rules, we're going to add a rule. And what an inbound rule does is it's basically the evaluation of traffic coming inside the resource, inside your VPC. So what that means is there are two different kinds of rules that you can set up with a security group: inbound and outbound. Inbound is basically the traffic, the security guard that's looking for traffic that's trying to access the resource. Outbound is basically traffic that is trying to leave the resource and head outside. So we're going to create an inbound rule here. And this inbound rule is going to say type HTTP. And then it is going to say the source type anywhere IPv4 and source 0.0.0.0/0. So what this inbound rule is saying is all HTTP traffic. So all HTTP traffic, you already know, follows a protocol, and it also has a port range of 80. This is something that we learned just now. And all of that traffic that comes from anywhere in the IPv4 kind of world, so any IPv4 address over here, 0.0.0.0, we're going to allow. So you're going to see that in a second how we're going to allow it. But basically this rule is just saying we're going to apply a rule to all HTTP traffic that is coming from anywhere on the internet. Anywhere being the 0.0.0.0/0. That was such a mouthful. And we're almost done. Well, notice that there's a yellow pop-out over here. And this yellow pop-up is basically a warning from AWS. It's AWS saying, hey, buddy, I'm seeing that you're creating a security group that's applied to all addresses on the internet. Are you sure you want to do that? Because if you're going to allow the traffic here, you're allowing all traffic coming from the internet. It's a bit risky. What if there's like some danger or like some, some traffic with some evil intents trying to access your resource? It's AWS saying basically that this is a bit too open of a range of addresses to accept. But really, setting the inbound rule to allow all this setup that we've just created, it's very, very typical, and it's absolutely necessary for public subnets to make sure that anyone on the internet can actually access your public resources. So don't worry if you see this banner. It's totally okay. It's totally normal for a public subnet to have this inbound rule. So you're going to notice, scroll down, did I click add rule for outbound rules? No, actually. This was already set up for us by default. So what's going on is by default, AWS security groups already allow all outbound traffic. By default, any security group you create, all outbound rule is already allowed by default. Unless you specify otherwise, any resource associated with the resource group can access and send data to any IP address. So any outbound traffic can leave the resource. So that is a great default rule to have because most of the time there isn't going to be a lot of restriction around what kind of traffic can actually leave your resource. Typically, what you're suspicious of is what's trying to access your resource. But since you are the one that created your own resource, you're probably feeling a little safe about the kind of traffic that wants to leave it. You can typically just allow all of that traffic out. And with that, I think we are ready to take a screenshot of your created security group and write some documentation about what we've just learned. That was a big learning, by the way. That was a huge learning. So let's click on create security group over here, and let's take a screenshot of our security group to write some documentation. So when you're ready, let's take a nice big screenshot, say cheese, to our security group, and let's write some notes down. Cool. In our documentation template, in the section that says security group, let us paste our screenshot over here. Ooh, very nice. I quite like this. I think this is not bad. I feel like it could look even better. So I'm going to double click on the screenshot I've just put in, and I'm going to drag it down like this. Because what I really want my screenshot to show is I really want it to, first of all, show the name of my security group, the fact that it's attached like to a VPC, but also the fact that there's an inbound rule in here right now. And that is the inbound rule that we created just now together. So I really want to have that in here. Cool. Now let's write down our prompts. Security groups are, I just noticed the chat, by the way. The chat, Isaac says cheese. So sweet. Okay, security groups are like security guards that monitor network traffic, monitor both inbound and outbound traffic at the resource level. I'm going to bold at the resource level because it's a very important concept that the Cloud Practitioner Cert, by the way, mentions a lot. The security group works at the resource level, i.e., every single resource in a subnet, in a VPC, has a security group. Extremely, extremely important concept. Security groups control traffic flow using two types of rules. Inbound rules are the rules that monitor or restrict inbound traffic. For example, inbound traffic is like users visiting a web app I'm hosting. Outbound rules are the rules that monitor or restrict outbound traffic. For example, what is something that is considered outbound traffic? So outbound traffic will be like my web app requesting data from a public source. So outbound traffic is basically your web app or the web app that's being hosted on an EC2 instance inside your subnet saying, oh, I need to visit an external source to grab some data that I'm going to display on the website. And that is absolutely data that's being requested outside and you're going out for it. So that's outbound traffic. Very cool. By default, an outbound rule, what is the default rule for all outbound rules? By default, an outbound rule will allow all outbound traffic. You want to go out? Head out. It's basically what this default outbound rule is saying. You want to go out? Go. So let's write that down. And iconic Nat move to now decrease the font size one more time to talk about the last bullet point. Ooh, Isaac, by the way, also suggested a great outbound an example of outbound traffic. Maybe the web app requesting updates from an external source. Absolutely, Isaac. I feel like we read each other's minds there. There was a bit of telepathy. That's cool. I also configured an inbound rule that, what did you set up for your security group's inbound rule? The inbound rule that we set up was, do you remember? Teasing you now. I also configured an inbound rule that allows all inbound traffic, all inbound HTTP traffic. Cool. So that is a wrap on security groups, and we can now visit the last step for today's project on creating a network ACL. So what we've just done so far in this project is we have set up traffic flow with our route table. We have set up some basic security with the security group that's standing guard outside every single resource in your VPC. But let's level up our VPC security and add something called a network access control list, otherwise called a network ACL over here. So how we're going to do that is in the left navigation pane, we're going to select network ACLs in the left-hand navigation pane here. Select that. And again, there are defaults. Oh my goodness, there are defaults everywhere, aren't there? But there are default network ACLs as well. And let's talk about what network ACLs are. So network ACLs are traffic cops stationed at every entry and exit point of your subnet, checking each data packet against a table of ACL rules before allowing them through. Whew. A bit of a dense sentence, I must admit. And this is absolutely something, again, is crucial to AWS VPC basics or Amazon VPC basics. And what a network ACL is really doing is it's kind of doing what a security group does, but at a subnet level. So remember how we say a security group is stationed outside every single resource. It's just standing there. It's standing guard. It's saying who can enter and exit the specific resource. But a network ACL is doing the exact same thing for an entire subnet. So that's why a network ACL is standing guard outside your subnet in this diagram. Okay, so imagine if before you can enter any kind of suburb in a neighborhood, you have to go through a security checkpoint. It's kind of like when you're driving down the road and police are doing like spot checks on cars. It's kind of like if that is a guaranteed check you're gonna have to do every time you enter a suburb. There's gonna be like a row of cop cars that's just standing there and checking every piece of traffic that's gonna enter this neighborhood before you can even get into the neighborhood. And you might be wondering, but I already have security groups outside my resource. Why do network ACLs exist? So let's talk about that a little bit, and let's talk about the differences. Network ACLs, again, are used to set broad traffic rules that apply to an entire subnet. For example, it can block incoming traffic from a particular range of IP addresses, or denying all outbound traffic to certain ports, where security groups allow for more granular control, managing access to individual resources. Now, you can specify which ports and protocols are allowed for each connected resource for a security group. And really what this means is if a network ACL has really broad traffic rules saying, okay, all traffic from this specific range of IP addresses cannot access this entire neighborhood, or it can say all different kinds of, all different like trucks and all of the taxis can't enter this neighborhood. Um, and the reason why you could want a network ACL is it's because it's great for managing security in a mass level. Because imagine if network ACLs don't exist, but you have a project where all of the resources in that project share the exact same security inbound and outbound rules. Imagine if you had to set that at the resource level for every single resource in your project that just share the exact same rules. You're gonna start thinking there's gotta be a better way to do this than going into every single security group and maybe changing some of the settings. Um, Having a network ACL at the entire subnet level is great to set those broad traffic rules up front. But security groups, of course, is just a really, really great fallback option at the very least to have if you ever want to just have that special security group inbound rule for this specific resource in your neighborhood. Um, it's like saying it's like saying everyone in this neighborhood is going to be protected from this specific resource, from this specific kind of traffic. But for this specific building, who is somehow paranoid or somehow afraid of this other kind of traffic entering, we're going to make sure that your security guard, your security group, is going to be also watching out for that and blocking that kind of traffic as well. I think that granular level of security just gives you so much control and power around how you want to manage the security of all of your resources inside your VPC. So having both is just really great security practice. You can set those broad restrictions at the subnet level and then specific limits at the resource level. This dual layer of security, oh, there's a typo here. This dual layer takes security really to the next level. And traffic must pass through multiple checks now because every traffic must pass through a network ACL in order to get into the subnet, in order to get into the neighborhood, and it also must pass through the security group for the specific resource that it's heading to. So that dual layer is absolutely great for security practice too. Okay, the other thing to address is this definition of network ACLs says that your network ACLs check each data packet. Oh, by the way, Tam in the chat says, is network ACL superior to a security group? Wow, great question. I think it's very hard to say that one is superior over the other. You can think of them as two things that really work together. I would say a security group is great for granular control. And then again, the network ACL is great for broad level control. They do similar things, but because they're at a different scope, they work together instead of against each other. So there really isn't one that's superior over another. I know that's probably not the most satisfying answer out there, Tam. But if you have any other things that you're curious about that, let us know in the chat. It's a very, very good question. Joe says, never heard network ACL described as neighborhood watch, but makes sense. Yeah, Isaac, that's a really, really great example. NACL are like the neighborhood watchmen. Completely true. Completely true. They go around and protect the entire neighborhood instead of just one specific house, which is what the security groups do. Now, the thing that we should definitely talk about as well is the fact that network ACLs are checking data packets against a table of ACL rules. What are data packets? Because we haven't actually talked about data packets before, and I think it's a really good idea to learn about data packets. What we're going to talk about right now is something that is very, very true to networking, or something that has always existed in the world of networking but never really gets discussed in our day-to-day kind of conversation, our day-to-day language, because it's slightly technical. Whenever we talk about, wow, someone is trying to visit my website, we're like, oh, this is traffic coming in, this is traffic coming in. But when we talk about traffic moving through a VPC and AWS, we're actually talking about data packets. We're actually talking about data trying to move from one place to another in a huge network. That is traffic. Data packets moving. So, for example, when a user goes onto their browser, they go to Google and they try to type something in here, something.com, press enter. There's actually data packets that's moving right now. That's the traffic that's going from the user's browser to the server that's hosting that website or the web app. How that data packet will be moving is that user that's entering the website's URL and pressing enter, they're actually sending data packets that represent a request. It's like saying, can I visit this URL? Can I see this URL's content? Can I view the website? For example, can I view like the index.html file? Can I view the image assets that are associated with this HTML file? It's like a request that's being that's being captured in these data packets that travel across the network. Travel, for example, through the internet to the internet gateway, and then through your VPC into the subnet, through like the security group into the actual resource are these like data packets that's traveling. So what is happening here is the network ACL, your security watchmen, or the people that are handling security at the subnet level, they're inspecting and managing every single one of these packets as they enter and exit your VPC subnets, making sure only the authorized data can come in and come out of your subnet. So again, here's another technical thing that you're learning. And I think that really is the beauty of any networking project, is you're going to end up learning a lot more than just what you're doing inside the console. For example, in this project, we just learned about what are protocols, we learned about what are port numbers, now we're learning what are data packets, just as an outcome of learning what is going on inside of VPC. It's so cool. It's really, really cool. And it's really why there's going to be just a lot of learning in this entire project series as well. Cool, so that was data packets. And if we were to talk about, if we were to come back to that difference between the security groups and the network ACLs, this is an image that you can use to try to picture what's going to happen. Imagine if your VPC was bigger than just one subnet. It had two subnets. What's going to happen is each subnet will have their own network ACL. As we mentioned, network ACLs work at the entire subnet level. So that's why there's going to be two ACLs now. But notice how there is going to be a security group for every single resource that's inside that subnet. So even though having two subnets creates just two network ACLs, and for the security groups, having a new EC2 instance is going to create a new security group that comes out. So I hope this diagram helps to illustrate that difference in scope between a network ACL and a security group. Again, security groups work at the instance level, network ACLs, the subnet level, that bigger border around there as well. Cool. Very, very cool. So now let's talk about why there are existing network ACLs. The quick reason for that is that, again, AWS sets up default network ACLs for every single VPC in your account. This default ACL is designed to allow all traffic to move freely until you decide that you want to have more specific security rules for your VPC. So what that means is, if these default network ACLs don't exist, then there's nothing that is guarding your subnet and checking the traffic that is coming in and coming out. And what AWS is doing here is it's going to implement those security watchmen or that network ACL for you, but to make sure that AWS doesn't accidentally block traffic that you want to allow, these default network ACLs that AWS is creating for you is just going to allow all traffic. So it's kind of like security watchman that's like, I'm going to check you. Come at me. But everyone that it checks is allowed in anyway. It's just allowed in anyway. And everyone that's trying to leave the subnet is allowed out anyway. But that check absolutely needs to happen in order for your subnet to be protected at all. Awesome. Thank you so much. A shout out to Chugwudi in the chat for saying, liking the analogies used to describe the security group and network ACL. Interesting. Thank you so much. All right, let's keep going now. And let us investigate the network ACL that's associated with the public 1 subnet. So how do you know if a network ACL is associated with which subnet? Here, the associated with column is really helpful for that. So we can see that between the two default network ACLs that exist, there's already one that literally says public 1 right over here. So thank you very much. This is definitely the network ACL that's associated with my public subnet. So this is what we're looking at, this row right here, is like the community watchman that's protecting the public subnet that you've created. Very cool. So what are our community watchmen doing? Let's check them out. So inbound rules. Inbound rule, all traffic, allow. Outbound rule, all traffic, allow. How easy was that? So what these inbound rules and outbound rules are saying is any traffic that wants to come in, come in. Any traffic that wants to go out, go out. You're allowed out. You might also notice, well, we have allow at the top row, but what about the bottom row? Hold on, it says denied. So is all traffic allowed and denied at the same time? Why does this row exist? Yeah, so what's happening here is notice what's happening in the rule number column. So our rule number column has a 100 and it also has a star. Okay, this is the key part. So what is happening right now is this star is considered the fallback option. The fallback option that is going to apply if your network ACL doesn't already have a rule for a kind of traffic that's coming in. So let's say, hypothetical scenario, your rule number 100 doesn't have a source that says all IP addresses. Imagine if this source here was a very specific IP address that just says, yeah, all traffic that's coming from this very specific IP address, let's make it like, 1.1.1.1/32. So only this IP address 1.1.1.1 is allowed. Then the star is the catch or the fallback option that's going to apply to all traffic that doesn't meet the top row's criteria. So you can think of the bottom one, any rule number that's a star is the fallback option that applies if any of the rules above that don't have a source that applies to the traffic that's coming in. And in our scenario, is our fallback option ever going to come into play? Is this deny ever going to come into play? No, it's not going to ever actually come into effect. Why? Because the top rule that we've created is allowing all traffic. Our IP address range is so open, it's literally saying it applies to all IPv4 addresses. So it doesn't matter that the bottom row says deny all traffic, because the top row that allows all traffic already covers all of the IPv4 address that your security group that your network ACL could ever be evaluating. And the same goes for the outbound rules. So I hope that was clear. What would really make this fallback option, this catch-all row at the bottom here, effective is the scenario where our source here is very specific and doesn't apply to all IP addresses. That's when the fallback option might come into play or might come into effect. Oh, Karan in the chat says, awesome session for the beginner. Thanks. Oh, that's so cool. That's so cool. Thank you. This is exactly why we do what we do. It's exactly why we do what we do. Oh, that's so sweet. Thank you so much. All right. So, to be honest, we're honestly so happy with this default network ACL that's been created by AWS. AWS covered everything that we need to have for our network ACL. Technically, this is all we need. This default network ACL has done everything we need it to do, because we have a public subnet over here, and we've already just said that we want our public subnet to pretty much accept all incoming traffic coming from the internet. And that's exactly what this default network ACL does. It allows all incoming traffic. So do we actually need to create a network ACL? No. No, we don't need to create a new network ACL. This default network ACL is all we need. And it's already associated with the public subnet. Let's be very clear about this. It's already associated with our public subnet. So this network ACL is already doing what it needs to do for the public subnet that we've created. So technically we don't need to create anything new, but are we going to? Yes, we are. Let us just recreate this network ACL that's been created for us. Let's just recreate it for the sake of learning. I'm going to be very, very clear here. You don't need to create a new network ACL for your public subnet because this default one that's been created for you already covers all your bases, already does what we need our network ACL to do. But the reason why we're going to create one in this final step of this exercise is purely for learning purposes. So are we ready to learn? I hope you are. Let us select Create Network ACL on the top right-hand corner. Click that. And what are we going to call this custom network ACL we're going to create? Let's just call it Network ACL. I quite like that name. And the VPC it's going to apply to. So our VPC is the Network VPC, the city. And let us create it straight away. Done. We've just created it. Now that we've created a network ACL, this is the one that we've created. We've named it Network ACL. Let's select it and let's check the inbound rules tab. Interesting. Look at that. By default, a new network ACL that we create is denying all traffic by default. Oh, interesting, isn't it? The default network ACL that was created for us without us having to lift a finger is doing what we needed to do. It already allows all inbound traffic. But for some reason, when we try to create something custom, by default, it's denying all inbound traffic. And this is just a security measure by AWS. It's also something that's quite important when you're studying for the AWS Cloud Practitioner, actually, something that actually you might get assessed on, is the fact that default network ACLs that AWS creates for us allows all inbound and all outbound traffic. But if you're creating a custom one, if you're clicking that Create Network ACL button and you're creating a network ACL for yourself, what's going to happen is AWS is actually going to automatically deny all traffic for security reasons for you. So very interesting point. So what we're going to do now is going to say, well, thank you so much for the security measure, AWS. I appreciate your concern, but I'm actually going to want to allow all inbound traffic because this is a public subnet that we're talking about. And we want our public subnet to accept all incoming traffic. So let's click on Edit Inbound Rules over here. And let us add a new rule and say that rule number is 100 classic. The type will be all traffic. And the source here, do we allow it? Yes, we do. And you might be wondering, why is 100 the rule number we're writing in here? This is honestly just industry standard practice. It can actually be any number you want it to be. 100 is just the classic one to go for, really. And as a little tidbit for you, in network ACLs, rule numbers decide the order that the rules are checked. So you know how these community watchmen are checking every single data packet and they're evaluating whether or not this data packet can come into the network, can come into the subnet or leave the subnet. How it checks it is it, again, starts at the lowest rule number in their rule book, in their list of rules, and then go their way up. So starting at 100 gives you room to add some new rules before this rule. If you want to have a rule that your network ACL checks first before this rule, it can definitely do that. If you create a rule that's like 1 or 2 or 50 or 99, any rule number that's lower than 100 will get checked first now. And really, 100 is great because you can also create some bigger numbers to say, oh, these are some other rules that you want to add in that you want to check after this rule that you've created. So as a recap, or like in short, what's really happening is typically the very first rule that you write in custom is going to be called 100 to give you space to add rule numbers before it and after it as well. Cool. And yeah, we've just allowed it all traffic, which means all kinds of protocols, all kinds of port ranges is allowed into your subnet. So we're going to save those changes. And your challenge is to just recreate that for your outbound rules. And it's, as you might have noticed, is going to look exactly the same. So let's edit the outbound rules, the traffic that wants to come out. And let's just add a new rule here. Let's call it 100. We're going to allow out all kinds of traffic. And done. Save the changes. And that's our outbound rules sorted as well. So good. So fast. So are we finished? Does that mean our network ACLs is done? Look at this and let me know. Do you think our network ACL, our work here is done? The answer is no, actually, it's not done. Do you see how this is empty? There's a dash here. So what that means is there's still one last step we need to take, and that is to associate our network ACL with our public subnet. So what scenario is happening now is we have set up a group of security community watchmen that we've just said, hey, community watchmen, I have recruited you today to allow in all traffic and to allow out all traffic. And the security group men are basically right now staring back at you and say, sure, we can do that. So which community are we watching over today? Where are we going? Which community are we actually looking after right now? It's not associated with any subnet, so it actually doesn't even know where to go to start doing its community watchman duties. So let's tell it where to go. Oh yeah, you're ready to start. Oh yeah, of course. The community that you're gonna be looking after with these rules is called public one. So go to public one, please. Is exactly what you're doing by editing your subnet associations and creating this association. Perfect. And do you see this little tidbit? Do you see how the moment I associated this new network ACL with my public one subnet, do you see how this has become the dash now? It's no longer associated with my public subnet. Interesting, isn't it? So what that means is only one ACL can be associated with a subnet at any time. This means once you associate a new network ACL for your public one subnet, the previous one is no longer associated with public one. It's kind of like saying only one group of community watchmen can look after this subnet at any time. You can't have two groups of community watchmen. Sorry. Only one group has the honor. So now that that's done, let's wrap up our learnings about network ACLs by writing our documentation. So take a screenshot of both the inbound rules and the outbound rules, and let's paste that into our documentation template today. So screenshot 1, add to your documentation over here. Let's make sure that we drag our screenshot right in here. Ooh, it's looking spicy. But let me show you how we can edit this frame. And let's look at screenshot 2 as well. Let's click on outbound rules. Let's take a screenshot of it. Outbound rules. And let's again add that to the page. Perfect. Looking good. So here's a quick Canva tip. I'm not very excited about the way my screenshots look in this frame right now because a few things are cut out on the edges, aren't they? So what I'm going to do is I'm actually going to drag down. Do you see how there is a little tab at the bottom of my frame? I'm going to click on that and just drag it down like that. Beautiful, isn't it? So now my frame perfectly captures my entire screenshot. I'm so happy with that. Let's do it again for my outbound rule screenshot. Let's click on the tab at the bottom of my screenshot. Let's drag it up. Great. That looks great. And there's this extra little thing here that definitely needs to be deleted. Cool. That's done. Looking good. Now that my screenshots are in, let us head to this page to write a few notes. Network ACLs. Oh my goodness. We have learned so much in this step, haven't we? Network ACLs are like community watchmen that secures my network at a subnet level. The difference between a security group and a network ACL is their scope, i.e., a security group secures resources at the resource level. At the resource level, secures my network. I'm going to change that to a security group secures my network at the resource level. So every single resource in my VPC is associated with a security group. While network ACLs secures my network at the subnet level. Every single subnet in my VPC is associated with a network ACL. And I'm going to bold the words resource and subnet just to make things very clear. Having both, oh my goodness, I should probably zoom in, shouldn't I? Having both network ACLs and security groups is a good security best practice because I'm going to say because this creates a dual layer of security. This creates a dual layer of security that makes sure I just noticed some activity in the chat, so I'm going to quickly adjust that. Thanks for the awesome session today. Thank you so much, Supriya. Hope to see a lot more in the future covering all other concepts of AWS, along with labs in the future. That sounds great. We want you to have a session in the future that will cover how the present concepts that you taught today is applicable in the industry or the corporate scenario. I love that. And you absolutely will. I'm very, very excited about more in-depth projects that are related to industry, that is related to corporate scenarios. This will definitely come through when the Cloud Practitioner course comes out later this month as well. So this is absolutely something that we're thinking about too, Supriya. I'm glad we're on the same page about it. So having both network ACLs and security groups is a good security best practice. It creates a dual layer of security that makes sure inbound or outbound traffic go through at least 2 checks. Now, similar to security groups, network ACLs use inbound and outbound rules. A default network ACL's inbound rule is set up to allow all incoming traffic, correct? Or allow all incoming traffic. A default network ACL's outbound rule is set up to allow all outgoing traffic. In contrast, a custom ACL's inbound and outbound rules, I think the important thing to highlight is whether it's default or custom. In contrast, a custom ACL's inbound and outbound rules are automatically set to deny all incoming, outgoing traffic. There you have it. So we've just wrapped up the main parts of our documentation. So that is awesome. And let us have a look at this quick recap here. So fantastic Amazing job. You've done an incredible job setting up a functioning VPC. So let's just recap that VPC setup now. Here's what's going to happen if you were to set up an EC2 instance in your public subnet, so this EC2 instance over here, and you were to host a web app inside your public subnet. What's going to happen in that flow of data packets or that flow of traffic? So let's say you have set up a web app in here, and that web app is hosting that you have set up an EC2 instance in here, and that EC2 instance is hosting a web app, and that web app is public to the world. You have done the exact setup that you've just created in this project today that is going to make your web app public to the world, and it is now time for users to visit your web app for the first time. Amazing. So what's going to happen is first, a client or a user enters the URL of your website into their web browser. They're going to type in suprio.com. They're going to type in joe.com, nextwork.org. They press enter. The moment they press enter, what they're doing is they're sending a request in the form of data packets. So these data packets are capturing a request right now. And this request is being sent from the user's browser all the way through the internet and reaches the internet gateway that's associated with your VPC, Nextwork VPC. So your request knows exactly how to get to the server that's hosting the website that the user is requesting. Okay, so those data packets are like making a beeline over there, and they hit the internet gateway. And then the internet gateway just says, "Oh, you're from the internet. Where are you trying to get to?" And then the traffic says, "Oh, I'm trying to get to this specific VPC in your account." And your internet gateway says, "Okay, here you go. Here's the VPC that you're trying to here's the VPC that's holding the EC2 instance of the web server that you're trying to access." The traffic says, "Oh, thank you so much." On the journey it goes. So the internet gateway says, "Okay, here's the VPC." And now your traffic has entered the VPC. And now the user's traffic has entered the VPC. Well, it's in this new land now. It's kind of like this traffic or these data packets have driven into a new city or maybe even into a new city within a completely new country, and it's going, how am I going to get there? That's where the route table is going to come in. So the route table is saying, where are you trying to go to? What's your destination? And the data packets say, I am trying to get to this specific IP address, which is going to represent the web server that's hosting your web app. The EC2 instance is hosting your web app. It's going to say, I'm trying to get here. Your route table reads the address that this client traffic has mentioned, and it goes, oh, I recognize this address. You're trying to get somewhere local, aren't you? Then head on to the local route. It's going to take you to where you want to go. So the traffic says, oh, thank you so much, Mr. Route Table. Let me head my merry way on the local route to the public subnet, where that web server is living in. So now route table is given kind of like the GPS or the directions, and the data packets are making their way now to the subnet, to the neighborhood that it knows that the web server or the EC2 instance is living in. Now, before it can even get into the neighborhood, over here, number 5, a network ACL stop it in its tracks. It says, stop. I see you're trying to get into this public subnet, into this neighborhood. We are the community watchmen that are protecting this public subnet. Can you please tell me about yourself? Where are you from? Where are you trying to get to? And these data packets are saying, oh, hi, I'm from this user that comes from this IP address. And the purpose of this visit today is to visit the web app that my user is trying to visit when it entered the URL and pressed enter on their browser. can I please come visit the public subnet? And the network ACL, the community watchmen are like, oh yeah, sure, of course, come in. Our inbound rule is actually to just allow all traffic in anyways. And the traffic goes, oh, okay, I guess that means I'm let in. Network ACLs are like, yep, you're let in. Then your traffic goes in its merry way inside the subnet now. The network ACLs has given your traffic its approval. It can now enter the neighborhood where your web server or the EC2 instance is living in. Now, the traffic has made its way to the front door of the web server or the EC2 instance. And at the front door is a security guard. And the security guard says, hi, I know you've talked with the community watchman, but I'm just going to make sure that the traffic or what you're bringing in is something that I can accept as a security guard for this web server. So can you please tell me about yourself again? And the traffic's going to say, oh, hi again. Yeah, of course I can introduce myself one more time. Hi, I am coming from this IP address, and the purpose of my visit today is to visit the web app that my user has requested to see. Security group goes, oh yeah, of course, you can come in. My inbound rule is actually to allow all traffic coming in. And the traffic goes, oh, okay. Again, same situation, I'm let in. Then the security guard lets this request through. This request goes through the correct port that belongs to HTTP traffic. And then it grabs the data it needs and it heads its way back out. It takes all of the website files that it needs to display, that the user wants to see on the browser, and it says bye to the security group. It leaves the neighborhood. It says bye to the network ACLs. It goes the exact same route out. It says, the route table goes, oh, this time you're heading back out to the internet. Yeah, here's the way to get to the port or the ship that takes you out, the internet gateway, that takes you out of the VPC. And then you get to the port, you get to the pier that takes you out of the city. That's the internet gateway. And then that zaps you back, zaps the traffic back to the client that has requested this, this web app in their browser. So that is an amazing flow of data packets through this entire VPC network setup that you've created from scratch. So kudos to you for doing all this. Look at that. An amazing journey, isn't it? So to finish off the project, definitely recommend that you wrap up your documentation by filling in the key learnings, swapping this photo for a photo of yourself, and you can absolutely swap out all of these photos in here as photos of yourself as well. Please also add in your favorite screenshot into this main page over here that can go into your title page. And once you've done all that, also make sure that all of the your name sections, the profile photos, and the LinkedIn links placeholders are replaced with your own details. And that will make for an amazing customized documentation, wouldn't it? So when that's done, you can share your work. You can get added to Nextwork's Secret Hall of Fame by sharing your PDF in the Nextwork community. So click on this link and make a comment, write a post about the project that you've just done. Something to be extremely proud about. Everyone celebrates these achievements. It is something to really be like, you did that. You created that. You finished that project. Heck yeah. Back yourself and shout it from the rooftops. Show us your amazing work. Please, please, please do that. It is one of our favorite things to see. And then next, you can share it on LinkedIn. It is so easy to share on LinkedIn. All you have to do is click on this link. That's going to open up a pre-filled post for you, ready for you to use. So if you click on that, there's going to be a post that's already right here that has everything you need to pretty much press post right away. All you have to do is click on the little X's here, click on that, and then click on the plus button at the bottom here. Click on the little page icon that lets you add a document. Click on choose file over here. And then you can attach the documentation that you've written. So here's an example documentation that you can attach. add your document title. So this document title can just be VPC traffic flow and security, for example. So you can put that in here. Press done, and then you can press post, and off it goes into the world. So that is extremely simple. All of the copy is already here ready for you. And when you're posted, make sure that you're tagging Nextwork. So over here, make sure that you double click on this and you click the Nextwork from this drop down, and this will make sure that everyone in the Nextwork team will know that you've posted and can go and say congrats and say hi and push your post out to more people on LinkedIn. Yeah, it's awesome. It's just such an awesome way to celebrate finishing a project together. Cool. Now that all of that's done, let us delete our resources for today. I think it is a great practice to challenge yourself and think about whether or not you can delete all of today's resources on your own. Hint, hint, it's actually very simple today. Because everything is contained within the same console, actually all we have to do is delete Nextwork VPC. So let's click here, Actions, Delete VPC, and let's type in delete here. Let's press delete. And let's check all of our pages just to make sure. So when you're checking, you can be like, oh my gosh, my public subnet's still there. No. Again, click refresh. Refresh that thing, and you're gonna see the public subnet's not even there anymore. Route tables, same thing. It can be like, oh, the route table I created, is it still there? Refresh. Gone. The route table that was associated with your VPC, gone. Nextwork, my Nextwork internet gateway, refresh that. Gone. Same thing with your network ACLs. Refresh that. Both gone. Security groups. Let's have a look. Oh, it's not even there anymore. It's already been like refreshed for us. Yeah, the one thing that's left there is the default security group for the default VPC in your account. So all you have to do is delete that one thing, the VPC. Everything else gets deleted with it. So very simple deleting process for this project. Linda in the chat says, thank you, Nat. It was an awesome session. Learned a lot. I love Nextwork. Linda, thank you so much. Wow, that gives us a really fuzzy feeling. That is so sweet. Thank you so much. And yeah, with that awesome sweet note, shout out to Linda. We are done with today's project. That is a wrap. Oh my goodness, that's networking project 2 done. Today you've learned how to set up route tables. You've configured a route table in your VPC to send internet-bound traffic to your internet gateway, turning your subnet into a public subnet. That's absolutely what happened. You implemented security groups. So you created a security group that will control inbound and outbound traffic at a resource level, specifying allowed IP addresses, protocols, and ports. And then the third thing is you deployed network ACLs, that middle thing here. You set up network ACLs as an additional layer of security, managing both incoming and outgoing traffic at the subnet level. Yeah, so that was extremely helpful. We've figured out traffic flow and we figured out security in 2 different levels in today's project. So that was amazing. It is wild that all these learnings are packed in one project. Great work. We'll see you in the next one. Don't forget to click that mission accomplished to celebrate it, that you've completed all the tasks. Go you. Chukwudi in the session says, super duper session, got so much value. Woo! Wow, that's so cool. Thank you so much, Chukwudi. Joe says, awesome as always, Nat. Great session. You are amazing as always as well, Joe. Thank you so much. It is just such an honor. It is such a pleasure to be doing this. And can't imagine doing anything else. Really can't. This has been so much fun. As we mentioned just now, we'll see you in the next project. And in the meantime, let's stay in touch and let's celebrate us finishing this project in the community as well. Can't wait to see your project documentation posts. Can't wait to see you share about this on LinkedIn. Can't wait to see you help each other out in the chat, in the community with questions, whatever it is. It's always such an amazing vibe. So thank you so much. And yeah, see you in the community. Bye. Thank you, everyone. See you.